In the halls of the College of Engineering, University of Saskatchewan, a team of students are developing an electric cargo vehicle. We are Shock and Roll Transportation, and at this stage we are designing a prototype to prove our concept. Cargo vehicles are significant contributors to pollution. We need to develop a cheap, aesthetically pleasing, sustainable, and battery-powered solution to replace existing vehicles. To prove our concept in the competition, our prototype must climb an inclined surface in less than 30 seconds, carrying as much weight as possible. With this in mind, we began our research. Looking through existing solutions, we gained some valuable insight. This allowed us to move forward with ideation. After some brainstorming, we came up with 4 unique designs. The treads, with 2 sets of powered wheels and 1 extra set to distribute the load. The treads were added to increase traction and would be made of rubber. The big wheel. Its 4-wheel drivetrain powers a set of small and big wheels. This size difference leans the body forward, keeping any cargo from slipping on an incline. The winch. A simple rear-wheel drive machine with an extra motor on top powering a winch. At the end of the string, a hook is attached, which can be secured to any surface. And finally, the Classic, modeled after a typical semi-truck, with a simple 4-wheel drivetrain powered by 2 motors. After evaluating each design against our objectives, we chose the Classic. Its dual motors allows for high cargo capacity, while its low weight minimizes embodied carbon emissions and reduces costs. The semi-truck inspired design tied everything together with an appealing look. The body is composed of 2 steel rods and 3 3D printed adapters. The steel rods provide a strong structure, while 3D printed adapters allow for easy manufacturing and increased control over aesthetics. The front adapter houses the front motor and is modeled after a semi-truck to add visual appeal. Cargo will be placed on the center adapter with the option to add a pin for added security. The rear adapter accommodates the rear motor and the battery box, which holds the batteries necessary to power our machine. Both steel rods pass through each adapter, being secured with both epoxy and cable ties to assemble the entire machine. Finally, the motors were soldered in parallel to increase the total current supplied to the circuit, thereby increasing torque. And it worked. Even when loaded, our prototype was fast on the ground, and on an incline, it showed no issues, getting up in much less than 30 seconds. This gave us confidence for the upcoming competition day. We crushed our first 2 runs and set up for our 3rd and final of the day, and I'll just let you see it for yourselves.
Easy. Oh, there you go. Easy. No issues here. This definitely seems like one of them. I like those steel demos. Alright, way to go.
We could carry nearly twice our machine's own weight, which is a resounding success.